Welcome to my channel. Here today, we will be answering the question, what if we fell into a black hole? Before we get into this video, make sure to hit that like button for more questions answered. Also, make sure to stick around until the end of the video for some extra special facts. Alright, let's begin. Number 5. Time dilation and the event horizon. Have you ever wondered what would happen if something were to fall into a black hole? In particular, what would happen if a person were to fall into one? We already know that once something crosses the event horizon of a black hole, it can never escape. Not even light can escape from crossing the event horizon. But there are other things to consider as well. For example, when you look at a clock while standing next to it, time will appear to pass normally. However, if you were to move away from the clock very quickly, approaching the speed of light, then time would slow down relative to your motion. This phenomenon is known as time dilation. So what does this mean for someone who falls into a black hole? Well, according to Einstein's theory of general relativity, as an object approaches a black hole, the intense gravity causes time to slow down near the event horizon. The closer someone gets to the event horizon, the slower time becomes. For someone far away from the black hole, they would observe the person falling into the black hole moving extremely slowly as they approach the event horizon. Eventually, the person would appear to be frozen in time, completely still, as they cross the event horizon. From the perspective of someone who has fallen into a black hole, however, time would continue to pass normally. In fact, someone who falls into a black hole would not even notice anything unusual happening until they had crossed the event horizon, and it would be too late to turn back. So if you were to fall into a black hole, you wouldn't really experience anything different until you were already inside the black hole. Only those observing you from afar would witness the strange slowing down of time as you approached the event horizon. Number 4. Spaghettification. Another interesting phenomenon that occurs when an object falls into a black hole is known as spaghettification. As an object approaches a black hole, it experiences an extreme gravitational force known as the tidal force. This force is caused by the difference in gravity between the front and back of the object. The closer an object gets to a black hole, the greater the tidal force it experiences. And as the object gets smaller, the tidal force becomes even greater. At the event horizon of a black hole, tidal force is so great that it would stretch an object out into a thin noodle-like shape. Hence the name, spaghettification. It should be noted that this process would be extremely painful and would most likely kill any living thing that experiences it. The gravitational forces at play would be thousands, if not millions times greater than the Earth's gravity. So if you were to fall into a black hole, you would be subjected to these immense gravitational forces and would be stretched out like spaghetti. You may have heard before that if you fell into a black hole, you would be met with such a great force that it would crush you like a soda can. While this is partially true, the more accurate description of what would happen is that you would be stretched out to an atomic level, like melting cheese pulled from a hot oven. Number 3. The inescapable event horizon. Let's say you're floating in space and you notice a black hole up ahead. You might think to yourself, gee, I wonder what would happen if I flew into that black hole. Just as you're thinking it, you decide, YOLO, I'm going to find out. You go full throttle towards the black hole. You see the event horizon rapidly approaching. You're getting pretty close now. Can you hear that? It's the sound of your own death. As you cross the event horizon, the intense gravity of the black hole begins to pull you apart, stretching you out into a thin noodle-like shape. Your body is torn apart, and the atoms within you are ripped apart as well. You are completely alone now, lost in the darkness of the black hole. There is no escape. No matter how hard you try, you cannot escape the inescapable event horizon of a black hole. Once you cross it, there is no turning back. Even light cannot escape from a black hole, so don't even bother trying. You are doomed to spend the rest of eternity trapped inside this black hole. Unless, of course, you have some sort of superpower that allows you to travel through time and space, or maybe you could just avoid the black hole altogether by making a quick turn at the last second. But let's be real, that's never going to happen. Once a black hole forms, nothing can escape its clutches. So if you ever find yourself falling into one, don't bother trying to escape. Just give in and enjoy the ride, because there's no escape from a black hole. Number 2. The singularity and infinite density. When an object falls into a black hole, it eventually reaches a point known as the singularity. This is the center of the black hole where all of the mass is concentrated and the density is infinite. We don't really know what happens at the singularity because it is beyond the event horizon, and our current understanding of physics breaks down at the singularity. However, we can make some educated guesses based on what we know about black holes and gravity. What we do know is that the singularity is the point of no return for anything that falls into a black hole. Once something crosses the event horizon and continues to fall, it will eventually reach the singularity. What would you experience if you were to fall into a black hole and reach the singularity? Well, we don't know for sure, but we can make some assumptions. According to Einstein's theory of general relativity, as an object approaches a black hole, the gravity becomes extremely strong. This means that as you approach the singularity, you would experience a tremendous amount of gravitational force. This force would be thousands, if not millions times greater than the Earth's gravity. You would be utterly crushed by the immense pressure, and your body would be completely destroyed. So if you fell into a black hole and reached the singularity, you would be completely crushed and destroyed. Number 1. Portals and parallel realities. If you were to fall into a black hole, you might emerge in another universe, or perhaps even another dimension. Black holes are one of the most mysterious phenomena in the universe, and their strange properties have captured the imaginations of scientists and science fiction writers alike. One of the most intriguing questions about black holes is what happens if you were to fall into one? What would you experience? Where would you go? Some believe that falling into a black hole would transport you to another universe or parallel reality. This idea is based on the theory that black holes are portals to other dimensions or alternate universes. Proponents of this theory argue that since black holes are essentially gateways to other parts of the universe, it stands to reason that they could also be gateways to other universes entirely. If this is true, then falling into a black hole could potentially send you to a parallel reality, where the laws of physics are different, or where you could live a completely different life. Of course, this is all just speculation, and there is no scientific evidence to support the idea that black holes lead to other universes. However, it is a fun theory to consider nonetheless. What do you think would happen if you fell into a black hole? Would you be transported to another universe, or would you be completely destroyed? Let me know in the comments below. That's all for this video. Thank you for watching, and for joining me on this journey through the fascinating world of black holes. If you enjoyed this video, don't forget to hit the like button, subscribe, and share your thoughts in the comments section below. Till next time, keep looking up and keep exploring the endless wonders of the cosmos.